This is the Amp Hour Podcast. Released January 13th, 2019. Episode 425. An interview with Chris Osterwood. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Chris Osterwood of Capable Robot Component.
Welcome, Chris. How you doing?
I'm doing great. How about you?
Good. I'm assuming we're going to be talking about robots today. Is that a fair assumption?
That is a fair assumption. It's been
fair assumption for you for most days of the week?
Yeah, though differently in the last year than previously in my career. Taking a slight departure, but we'll get into that, I'm sure.
I'm sure we will. So how do you define robots?
That's a good question. The kind of robots that I've been working on that I enjoy working on are autonomous ground robots. So things that are 100-pound to 1,000-pound that do useful things in the real world that aren't tied to a particular work cell in a factory. So that's what I think of when I think of robots and when I say robots. But there's obviously a huge variety to the term. It's really amorphous
and growing too, it seems like.
Oh yeah, every day.
Yeah, I was talking to my girlfriend earlier about robots, and I was mentioning that we're going to record about it, and she started talking about something that kind of sounded like automation, and I was like, well, wait, we got to determine between automation and robots. There's all these different terms that kind of get mishmashed together, and so it'd be tough.
It is. And I actually wrote an article recently about automation versus autonomy. And there's a very subtle difference in those definitions that I think is an important one.
Could you define it here quickly?
Oh, man, that'll take too long.
Okay.
But
there's no two second overview, huh?
I need to spend some more time to get it down to 2 seconds, but capablerobot.com has the article. So if people are curious...
Okay.
But the high level is things that are autonomous have more agency and more self-governance than things that are automatic. And it's a minor point, but it sort of relates to the depth of understanding and freedom to operate that a system has. So something that's purely reactionary or purely deterministic, I would call automatic. But if there's more freedom of thought and expression in a system or indeterminism, then you start getting into autonomy.
Right. So if then else kind of loops are automation.
That would be automation.
Yeah. Right.
Yeah.
And so that seems very common these days, right? But it's not exact. It's not all of it. It seems like.
For sure. And you can accomplish great things with things that are just purely automatic. I mean, nearly all robot arms in factories are pure automatic. There's not really a higher level understanding of the world around that arm for it to operate and be very productive and successful in its task. But it gets a little bit trickier to sort of classify things when there's randomness in the behavior, but there's not a depth of understanding. And the first generations of the Roomba are a good example of that, where it doesn't do the same thing every time, but it doesn't really have great understanding of what it's doing either.
Right.
And I don't have a great answer of how you would classify that, but the newer systems they're building, I would definitely call autonomous because of the map building and the sort of depth of understanding that those systems have.
So somewhere between logic and fuzzy logic and then actual neural networks and stuff like that. Did any of those terms actually land, or am I just talking about already?
Well, I think that those are sort of ways that you could implement these sorts of systems, but they're not how you would define the system.
Well, let's go back a little bit. So how did you get into the field of robotics in the first place? Because it seems like a big, wide field that's growing a lot, and it seems like there's a couple ways to get into it. But how did you get into it?
I got into it. Let's see. So in high school, I had a summer job at a Java web services company back when Java server pages were the in-rage. And the guy that ran that was a CMU grad, Carnegie Mellon University, and encouraged me to apply there. And that's where I got introduced to robotics and where the whole trajectory of things that I worked on changed was attending Carnegie Mellon. And what I loved about the school was its focus on practical systems and field robotics specifically. The Robotics Institute there has a field robotics center that does things that most people would find not sexy in terms of robotics, but I found fascinating, like autonomous robots that went to the Chilean desert and looked for life, and things that mapped and monitored coal mines and all sorts of different autonomous and semi-autonomous systems out in the real world. So that really captivated me, and I was lucky enough to get in, and was a mechanical engineering student there, but really active in the robotics club, which saw tremendous growth. When I was there, we went from 20 students to over 100 over the 4 years that I was involved in the club, and started some student taught classes there. And then connections I made with the research that I was doing as an undergraduate led into all of the jobs that I've had since then.
That's great. And at CMU, was there was there a mechatronics type program? I mean, I don't know. It seems like there's a huge robotics focus, but I know a lot of programs are switching over to mechatronics where there is that combined electrical, mechanical kind of stuff.
Yeah, at the time, there definitely wasn't. I think there's likely more of that now, but at the time, and I still basically agree with this, that the field of study of electrical engineering is really large, and computer science is really large, and mechanical engineering is also really large, and trying to cram practical knowledge of all three of those disciplines, in addition to how do you think, how do you write, into 4 years as an undergrad, seems like a difficult task for any school. Mm-hmm. So it was definitely a segmented from a class perspective, but there were lots of projects and research happening that would pull people from all disciplines to achieve the research aims of whatever was happening. Mm. And that's the thing that I really love about robotics, is that you can't just solve problems with software. You just can't solve problems with the right electronics or with the right mechanism. It's really an integrated design in all three disciplines. So you're forced to work in cross-functional teams to solve the challenges that you're faced with.
Right. And I mean, so we talked about this with James Bruton a little bit when he was on the show a couple weeks ago, but the electronics doesn't seem, I mean, I know it changes, but it doesn't seem to change that much from iteration to iteration. It's because there's so much software stuff to do and mechanical, linkages and all the things that have to happen when you're making a different type of robot. Do you see a lot of things changing in the electrical side of things?
Yeah, but maybe not in the ways that people who are building consumer electronics or other things that are really electrically heavy.
Okay, so there's no motor driver chips that are being introduced at CES this week. Is that what I'm hearing?
Well, I think Trinamic's doing some really awesome stuff, and I'm excited to see what they come out with in the next couple of years, and the RISC-V processors that they're integrating into their motor controllers. I think that's a really interesting and really interesting move, and I'm really excited to see what they do. So there's innovation happening everywhere. Mobile processing has seen tremendous change in the last decade. What you can get per your dollar or per your watt is hugely different now than it was a couple of years ago. And that's really enabling, a whole new generation of advanced behaviors and robots that have much deeper understanding of the systems that they're interacting with or the world that they're manipulating.
Oh, interesting. So you'll see, within a robotic system, you would be kind of tracking upgrades based on a new ARM processor coming out, and you would basically use that to make a better motor controller or whatever.
Yeah, or something that has better understanding of the visual field that it's looking at,
okay,
or faster reaction time, or just longer operating life.
Okay,
when you're a mobile system, you carry your own power source. So, if you're a 100-pound robot, you maybe have 10 pounds for batteries, but that might be stretching it. And if you want to run for, 2 to 8 hours, that can be really, really challenging.
Yeah. Yeah, it's almost like the rocket what's the rocket equation where you have to kind of carry your own fuel, that kind of idea.
It's exactly the same thing, except you're not fighting gravity quite so much.
Depends what kind of robot you are.
I guess, yeah. But yeah, there are definitely compounding effects with the physical size and the physical weight of all of these systems. Mm-hmm. And they do feed on each other in sort of that negative feedback loop.
speaking of loops, let's loop back to
Hmm.
your history then. So
Yeah.
after school, you were doing a lot of club stuff, but you kind of got into the world of robotics and did that for work. What did that look like?
So I guess my first job in robotics was unpaid, in that I started a small company with two friends, and we didn't make any money, but we learned a ton.
Yep.
Uh, and it was a great experience. I would definitely suggest people do that if they have the inclination. And our company was called Botrix, and we built a little behavior-based robot controller called the Cerebellum, which launched around the same time the Arduino did.
Mm.
And we were PIC-based and serial-based instead of Atmel-based and USB-based. And that, and the fact you had to buy $100 compiler to use the chips and a whole bunch of other things, meant that, that went nowhere. But we learned a ton. We built some high-speed mobile diff drive robots as well. And
Is that
yeah, it
differential
was
drive?
through sort of, yeah, exactly, differential
Sorry,
drive.
I'm gonna probably try and disambiguate some terms here.
Yeah, perfect. Thank you. Yeah, and that led into my first job out of school at a company called Red Zone Robotics, which was founded to do nuclear cleanup, power plants and sites like that. Luckily, there are very few nuclear disasters, so they didn't have a lot of work, and that version of the company sort of went bankrupt, and then it was reformed to do sewer inspection robots. So dirty, dull, and dangerous.
I was going to say that could have, with that name, it could have gone one of two ways. It could have been either nuclear cleanup, or it could have been a robot that follows the football player as he gets behind the 20-yard line kind of
thing. Yeah, that is when you search for Red Zone, you get all sorts of different things that pop up, and a lot in sports, as you can imagine. So when I was there, I worked first on a robot called Responder, which was a 600-pound hydraulically driven robot that was designed for large diameter, deep tunnel sewer pipes, sort of 4 foot. Yeah, it was pretty neat.
I mean, you say it's not sexy, but like I mean, like that's amazing to me. Like
it was really a fascinating design challenge in many, many respects. And you have a robot that is under 80 feet of head pressure. It's 80 feet underwater.
Wow.
In a tunnel that is very constrained, that has high flow, high grit environment. And in some of the tunnels that we were operating in, we had to go out a mile or two because the access shafts are so far apart because the tunnels are so deep. They don't want to put an access shaft every couple hundred feet. It would be tremendously expensive to do that.
And like, wait, are you dropping? So you just like kind of lower it down into the shaft, or someone has to actually like go down and take it and put it in there?
No, you lower it down on a crane. And then when it sort of hit the bottom of the access shaft, you then would drive it out, hydraulic track driven system. And it would pull the power tether with communications back to an operating truck where a remote operator was monitoring sensors, sonar sensors, and IMUs and things like that to understand where the pipes were going and the condition of the sewer pipe that it was inside of.
Huh. And that was, and so you're saying this thing could kind of going upstream, like in an actual water pipe or something?
In a sewer pipe.
Oh, sewer pipe.
Which are, yeah.
Oh, high grit environment. Yep. You mean things that rhyme with grit.
Well, yeah, but that's not the worst part of it. Like asphalt's actually really bad. And in the United States, at least in old cities, most of the sewer infrastructure is what's called combined sewers. So it's like storm sewer and sanitary sewer combined. So it's really nasty down there, and the stuff that comes out of houses is very minor in terms of like the amount of volume that's in these pipes. It's all pretty diluted once you get to the 8-foot diameter pipes.
Oh, and it is like it's the if you'll excuse the term, the Ninja Turtle pipes, as I used to call them, the ones that you can walk in.
Exactly.
Yeah, okay.
Yeah, except they don't want to tell people don't use the sewer so that we can send a guy in there to inspect it.
Right.
You send in these robots. So it was a sort of mechanical engineer and system engineer on that system, and then went to the totally opposite end of sewer inspection robots, where we built a fully autonomous small diameter pipe system that was designed for sewer pipes underneath residential streets. So sort of a shoebox sized robot that was 10, maybe 15 pounds. It's been a while, sorry. Designed for 8 through 12 inch sewer pipes. And that one was actually fully autonomous, which introduced its own set of really interesting design challenges. So the concept of operation there is that you'd open up a manhole, lower this robot down, 4 feet to 20 feet, however deep the manhole is, to the invert where the pipe enters and exits in the bottom of the chamber. And then you attach a line to near the top of the pipe where you can still reach when you're on the street. And then you close the manhole and you drive away. And then the robot would fully by itself drive down the pipe, collecting video data and again, IMU data, and record that internally and automatically detect when it got to the end of that segment of pipe where it had reached the next manhole. And then it would return to where it started. And so you could be operating many of these robots simultaneously, get a lot more footage per day, and also you're not clogging the streets with a truck parked and blocking traffic as you're manually driving a system down the pipe.
Wow. And then this was all just to inspect to make sure if the pipes were intact, didn't have like tree roots going through or something?
Exactly, yeah. Holes, cracks, deformation, depending on the different materials, you have different kinds of, failures that can occur in the sewer pipe.
Are these like widely deployed? Like, I guess I'm not in this field at all, so it's not like I'd be like, oh, I've never heard of this. I have never heard of it, but why would I have? Are these widely used these days?
There are lots of those robots out there, but I can't get into exactly how many.
That's okay.
It's fairly this approach to sewer inspection happens all the time. Normally, it's just sort of a camera attached to some motors, and the innovation here was that you weren't dragging a tether behind you, and you didn't have to have a guy sitting in a truck defect coding while the system was in the pipe.
That's super. Yeah, that's great. And I guess I wondered who is this? Like, who is the end user of this? Is it like a municipality buys a bunch of robots, or is there a service that then sells this service to a municipality?
Yeah, in this market, it was both. Some municipalities had their own hardware and their own operators, and then some would contract with local firms or international firms, to come in and do a whole bunch of work all at once, and then use engineering service companies to triage all of the inspections that had happened and figure out where do my rehabilitation dollars go this year versus next year, and prioritize.
No, I assume that the way to do that previously was like you dig up the pipe and see if the pipe's got a hole in it. If it doesn't, you put it back under the ground. So that seems like a really good use.
Yeah, they've been using cameras, remotely operated cameras, for a while, but having the closed manhole during the inspection is really nice from a throughput perspective.
Well, that's great. That's great. And so, and you said in this one you had switched away from the mechanical side of things, or what?
I did some of that, but I guess I designed like the whole drivetrain mechanism on that system, sort of the bottom half of the robot, and another mechanical engineer did the camera system there. And then I was also the system engineer, and then eventually became the product manager for that product.
Cool.
Which was neat to get more interaction with end users and go on field deployments and really see how the system was operating. I have to say, one of my favorite bug stories of all time came from that period of work, where we got reports from field operators that there was a location-specific blue screen of death on the rugged laptop that was used to operate this system. So you needed to tell it what manhole ID it was at and things like that. And we scoffed at this because, a location-specific blue screen of death.
Like you mean like somewhere in a city makes it go to blue screen?
Yeah, like you drive down this road and at this one particular spot, you try to inspect the pipe and the laptop would blue screen.
Huh.
And, we laughed at this. And then we sent our software engineer, who was responsible for the operator control unit, out to the field. And he reported, it's totally repeatable, 100% repeatable.
Wow.
And it took a little while for us to figure out what was going on. But what had happened was that someone who lived on that road had created an SSID with a null character as the name of the SSID. So it was a zero length SSID.
Oh, man.
And Windows 95 or 98 or whatever we were using at the time, the Wi-Fi driver could not handle that, and blue screen the whole system.
Man. That's great. Yep. That's great. Never much to think of this.
So, I don't think we managed to get that fixed. We just said, well, this pipe can't be inspected.
Well, guess your house is gonna flood. Sorry about that, but it's your own fault. You shouldn't use that Wi-Fi name.
Exactly.
He uses a null character as a. Anyways.
I mean, if you wanted to be hidden,
I guess so.
Yeah.
So, like on the mechanical side, what does that actually entail too? I mean, is it like speccing in components? Is it speccing in motors, speccing in other stuff? What does it actually look like?
Yeah, it's a mix of understanding components that are available and appropriate for use in the system that you're building, in terms of size and power and capability and cost, and lead time can even be a way that you choose a component. And then also doing a lot of housing design and drivetrain design, sealing design, thermal considerations.
Can you can you define drivetrain here for us too?
Sure. I guess I'd call the drivetrain everything between the motor and the world. So the gear reduction and the interface between the gearing and the real world. Okay. So in these systems, they were generally tracked, but you'd have
like some a tank, kind of like a mini tank.
Yeah, exactly. Okay. Yeah, mini tank. But the design of the tracks impacts a lot of behavior within the pipe and how it interacts with grit and grease and all the things that are down there.
Right.
And then there's anti-clogging things that you need to do, so you don't throw a track off the system as it's operating. And then, gear reductions, because motors don't generally have the right torque and speed ratios for most operations. So you need either a motor, a gearhead that's built into the motor, or design one yourself that reduces the speed of the motor and increases the torque capability. And, packaging all that in small sealed systems gets really interesting.
I was going to say, you got to make sure the grit and the other stuff doesn't get in there too. And
Yeah. We spent a lot of time thinking about seals, static and dynamic seals, because if you have rotary motion, you generally can't use normal O-rings to seal those diameters because of the drag coefficients, and the seal life is just really poor. So you have to use things that are designed to seal against rotating shafts.
How much of this stuff is like learned on the job versus like university style? Because we talked a little bit about mechanical and the role of teaching in robotics and stuff, but like how much of that stuff was covered in classes?
I think the program that I was in did a pretty good job of balancing sort of theoretical mechanical engineering with practical mechanical engineering. We did things like bearing life calculations in class and drivetrain efficiency experiments and calculations, and had a reasonable understanding of the efficiency of spur gear trains and helical gear trains and bevel gears and worm gears and all the different kinds of ways that you can transform motion. But there's only so much that you can learn in a class, and there definitely is no replacement for building stuff and it not working, or building stuff and it works but it's too heavy or breaks too much, or
iterating and trying again, that kind of thing.
Yeah, exactly. Yeah, there was there was a period in this development of this autonomous robot where the first rounds of prototypes were breaking about every other time that we would deploy them.
Oh wow.
So once a day or twice a day. So we as engineers were out in the field, learning what was working and what wasn't working, repairing things, keeping detailed records of all of the failures that we had over months of operation. And then we use that to triage, the next development phase and figure out here's what we need to fix and how we're going to fix it. And an iteration later on that system, and we could operate for a month without any failures.
Oh, nice.
And failures in that environment included things like someone accidentally dropping the robot down a manhole and smashing it. So anything that caused service on the system, we wanted to record as an incident.
I'm wondering because, I hear this stuff and it seems very foreign to me, the mechanical side of things. And so I wonder about if I started from scratch today, or if our listeners started from scratch today, what is the, what are the kind of things that they would need to learn to get the first robot out there, for their basis?
I guess it really depends on where you want to start. If you want to build off of an existing platform, or if you really want to start from first principles, you can go all the way to understanding magnetic theory and building your own brushless motors, which I would not recommend as a starting point. But you can go really to first principles on this stuff if you want to. Um, and I guess it all comes down to what problem are you trying to solve, and how constrained are you in time or money or space? And that sort of make versus buy decision is one of the most important ones that I found myself making as an engineer. In nearly every project that I've been involved with, do we take something that's been designed for slightly different application, or do we build from scratch? And there's advantages and disadvantages to each approach as you're building a system. So yeah, there's sort of no great starting point from knowledge or building block. It really depends on the particulars of the system you're trying to build.
That's not the answer I hope for, but it's a very realistic answer.
Yeah, sorry about that.
That's okay. I mean, I think that starting from a kit makes a lot of sense for a lot of people, I think. And
oh, sure, yeah.
And then from there, learning those other things you're talking about.
Yeah. But a kit isn't going to, a drivetrain kit isn't going to help you if what you care about is a robot that has really good perception and object recognition. So there's so many facets to robotics that you really need to think about the problem that I'm trying to tackle here, and what's new and what isn't new, where I can just find things that exist and repurpose.
Right. What are some of the challenges that you're seeing? I mean, is it mostly vision these days and similar like processing type things, or is it other stuff that's out there?
I think there's a whole new world of exciting things happening there. I don't know that I wouldn't call it a problem, but it's definitely new fertile ground for people to be exploring it. And new problem space. Yeah. There's a lot happening there. It's such a broad field. It's sort of hard to pin down, but the thing that I'm particularly excited about to see in the next couple of years is more systems actually getting fielded and deployed, and there being more robots that you see in the out in the world in your daily life. Things that help, that enable new kinds of mobility, that enable people that have particular challenges, physically or mentally, to succeed in the world. Things that are, reducing agricultural runoff or efficiency of manufacturing processes. There's a whole host of challenges and things that we can attack with the technology that we have today. And fundamentally, robotics is not an industry; it's more of a approach to developing products and a tool set to use in solving problems.
Yeah, and I guess it's because the definition of what a robot is kind of flexible, anyways. Is a dishwasher a robot? That's a
no.
Is a Roomba a robot?
Yeah, absolutely.
Okay.
But if you asked a roboticist to build something to wash dishes, you wouldn't get a dishwasher. You'd get something with many arms and hands and a vision system, and it would break all your dishes for a while,
right?
Until it learned.
But isn't that a bad thing?
Yeah, I guess that's my point. Is that robots are not. It's a technology approach, right? It's not a solution, right? It's a way to solve a problem. And there are problems where robotics are definitely not the right solution. And there are other problems where robotics are the only solution. So you have to really think about the problem you're tackling and then go back from there. A great example of that was a system I worked on at Carnegie Robotics, which was 2 jobs later, where we had someone who was an agricultural engineer come to us with a new idea, or he saw a problem in fertilizing cornfields and the massive amount of nitrogen runoff that was happening in fields because this is the other thing about robotics, is you learn about all these fields that you wouldn't otherwise learn anything about. So,
and in this case, nitrogen, a literal field, yeah,
literal field, yes. So nitrogen is a fertilizer. It helps corn mature and grow, and the corn plants actually need nitrogen late in the growing season when they're 8 to 10 feet tall. But applying that nitrogen to the field then is really tricky and prohibitively expensive, because you need tractors that have 8 to 10 feet of ground clearance, so you don't mat down all the corn with your normal tractor.
Mm-hmm.
So what ends up happening is farmers apply nitrogen much earlier in the season when the corn is short, and then the rainstorms that happen wash most of that nitrogen away, and it ends up in rivers and, our groundwater. And
right. It causes like algal blooms and stuff like that, and lots of bad stuff.
Yeah. Yep. And nitrogen is actually the second most costly part of growing corn after fuel and equipment combined. Yep. So, it's it's seed that's the most expensive. Fuel is third. So it's seed, nitrogen, fuel. Mm. So if you can apply nitrogen later, it's good for everyone. Good for the farmer because they're spending less money. Good for the environment because there's less nitrogen runoff, less algae, less waste, all sorts of good. And the solution that we came up with to solving this wasn't automating existing tractors. It was building a robotic system that wouldn't be possible without sort of robotic technology and autonomous behaviors. So it was a 800-pound robot that would actually drive down a row of corn. So the system was 20 inches wide, about 8 feet long, and 3 or 4 feet high. Hydraulic robot that we purpose built just for this task, 4-wheel drive and a center body pivot, and the 200 gallons of nitrogen that it would carry were really low to keep it from tipping over. And we were, width constrained because of how corn is planted. It's a particular center to center distance on every, row of corn. And it would, drive down a row and spray nitrogen fertilizer right at the roots of the corn when the corn's 8 feet tall. And it doesn't matter that it's 8 feet tall because you're driving between the rows of corn, not above the rows of corn.
Right. Yeah, it's if people have ever walked, like I always love when they have cornfields and like Field of Dreams or something, they're like slowly walking through. It's like, man, it doesn't work like that. You get smacked in the face by like some of the strongest standing things ever. There's like those ball roots that are there. It's nasty.
It's a nasty environment to operate in. Yeah. And for a small system like this, things that aren't obstacles for a tractor that has 4-foot diameter tires are definitely obstacles for this sort of system. Rocks and roots and branches and all sorts of things that are in there.
Spiders.
Not
a big fan of cornfields, if you couldn't tell.
Apparently.
Yeah.
Well, now you don't need to go in them. You can use this system.
Yeah.
So it's pretty neat that you have a set of tools, and sometimes those tools like let you create a system that wouldn't make sense in any other environment, and it wouldn't make sense for a person to be operating this because it can only spray nitrogen on 2 rows of plants at a time. A normal tractor has these giant booms that stretch out, and you can fertilize 30 rows as you drive down with these huge gantry systems. And one person can fertilize an acre of corn really, really quickly when the corn is low. This system took a lot longer because it was going up and down every other row of corn, spraying nitrogen. But because it's autonomous, you could have multiple instances of this robot driving around a single field and coordinating. I'm going to go fertilize over here. You go fertilize over there. And when we're all done, we come back to the trailer that has dropped us off and we refill autonomously and, rinse and repeat. Yeah. And it was a fantastic system. And
is there uptake of this thing yet or no?
It's still in the sort of fielding stage. All the technology has been proven out, and the guy Kent, who's responsible for that, is wonderful, and I love him. And he unfortunately has not been able to raise the next round of money that he needs to build a whole bunch of systems to really get it to market. So many acres of corn have been fertilized, but unfortunately there are not hundreds of those robots out there yet. Right. There definitely should be. Right.
Well, and so like I was going to say another thing with the nitrogen fertilizer too is like that comes from ammonia, I believe, and that actually is like this really, really intense energy process, and that's like a big contributor to just carbon emissions and stuff like that for like because I think a lot of it's done with fossil fuel stuff. So that's like another benefit of it being gone or being lessened at least. So yeah, it's definitely a field. I mean, like I think the ag tech stuff is super interesting. Precision ag is really cool.
Yeah, there's a lot of neat things happening there. And, when you have robots operating in these fields, you can do all sorts of interesting health monitoring there are things that you can do on the ground that you really can't do from the air, from an inspection perspective. And there's real opportunity there. But there's this, there's a cost to deploying systems. So if you can build a system that's providing multiple value streams, right? Like fertilization and inspection and health monitoring. There's the real benefits.
Right, right. But you're also going against lots of traditional methods, things that are newer and traditional. So yeah, that's a tougher sell. Well, that sounds
Yep.
like a cool space. So what was this place at? That was Carnegie Robotics?
Yeah, Carnegie Robotics in Pittsburgh. I was there for about 6 years. Started as a senior robotics engineer, and then a couple years in, was promoted to be the chief technology officer there,
Wow.
and helped grow the company from, I guess when I started, we were 8. And then I became CTO when we were about 30 people, and I left a year ago when we were about 60.
Wow, that's great.
Yeah, it was a fantastic organization.
So what does a CTO do of a robotics company?
Many things. So I was doing a mixture of a sort of product development planning for internally funded sensor products, mainly stereo sensors, 3D vision systems, but also some inertial products that we were working on, and some project management on the custom system developments that Carnegie Robotics was doing, some business development, helping make sure that there are custom system development projects for people to be working on.
Yeah, right.
And then lots of interactions with customers on both the systems and the products to make sure that we're building the right thing and that it's working, and getting feedback and figuring out the next version and requirements and features and deployment strategies and marketing and all of that. I was also doing IP strategy and working on a patent portfolio, and also sort of a technical resource for the engineering team in design reviews and getting things unstuck from time to time. A fresh set of eyes can really help things move forward. And it definitely was not the case that I was definitely not the smartest person there or the one with the most knowledge, but just having a fresh set of eyes on things was often enough to get things moving forward again.
Yeah, that's great. That's great. What kind of people would come to I guess like a for-hire robotics company too. I guess I don't understand who would hire that kind of company.
Yeah, so it was, I guess, to answer that question, I'll start with where the company started from, which is the original idea was to be the commercialization partner for the National Robotics Engineering Center. So the National Robotics Engineering Center, or NREC, is part of Carnegie Mellon, but it's a research institution and not an education institution. So it built advanced ground robotics for people like Caterpillar and John Deere and the Army and a whole bunch of other people. And very, very successful organization. And the thing that they saw was that the prototypes that they were building weren't getting to market because NREC, by mission as a research institution, could not build product. Like, it was actually prohibited from selling product. It could only do research. And the people that were funding that research didn't have the technical capability to take those prototypes and turn them into real producible products.
Right. They're in the business
of a gap,
developing developing step by step and just slightly advancing their tech instead of introducing a whole new field to their stuff.
Yeah. And tons of really good engineers at all those places, but they're this at the time this was a brand new field, and that capability and technology understanding really only existed at the university. So NREC did lots of wonderful things, and most of them didn't see the light of day outside of tech demos.
That's a common thing, yeah.
Yeah, unfortunately. So Carnegie Robotics was started to be the commercialization partner, the bridge for NREC, and to take what had been developed there and to productize it, and did that on a couple of instances. But then we quickly found our own feet and our own products that we wanted to be building, and sort of built the business from there. So we were doing a mix of custom system development and component product development, as I mentioned, and working on things like that. Autonomous agricultural robot. We worked on industrial floor cleaning, sort of an 800-pound Roomba, the things that you see cleaning hospitals and
there's
airports.
Like big green ones that people are pushing that have like the spinners underneath that actually are...
Exactly.
Yeah, okay.
Or that you ride on top of. Floor scrubbers, burnishers. So we built a autonomous one of those for a company called Nilfisk that's really large in that space.
Mm-hmm.
And also had a really large multi-year project with the U.S. Army for robots that looked for mines and improvised explosive devices. And that was a really interesting project and a really fantastic project to work on from a getting people out of harm's way perspective.
So what? So then you left. You left a year ago. So now
I did leave a year ago.
You're not a CTO. You're a CEO now. So what are you doing now?
The problem that I'm trying to solve with my new company, Capable Robot Components, is make it easier for past me to build the systems that past me was building.
So this is the builder buy. You want to make the things that someone can buy it?
Exactly.
Yeah,
yep.
Okay.
So that was continuously frustrating to me was, we can build this thing, but this thing is not key to the problem that we're trying to solve is, but we have to do it because the things that have been designed for telecom or for fixed factory automation or for consumer electronics or for agricultural applications aren't appropriate for this task or this platform or this environment or whatever. And, robotics, as big as it is still a really small industry. So
right.
There isn't the component supplier network there that I believe should be or could be. And that's why I started Capable Robot Components. And the whole mission's in the name, building components for capable robots.
Yeah. So what kind of stuff are you building?
I'm first starting with underlying infrastructure. So a gigabit Ethernet switch on a card that's designed to embed into a larger power or data distribution system, trying to encapsulate all the complexity of that circuit onto embeddable module, and a similar take on a USB hub, which doesn't sound very exciting, but most USB hubs don't have any diagnostic or capability of reporting, don't have power monitoring, don't allow you to power cycle downstream devices or disconnect them or understand the health of the system. So building a USB hub that does that, and some test equipment as well, and then next working on some camera systems.
Nice.
That I'm excited about. Yeah.
I'm curious about the fact that you couldn't buy this stuff because the gigabit Ethernet. So what about it? Why weren't you able to just buy something off the shelf? Is it the stuff was there, but it was two extremes of one was commercial and super cheap and chintzy, and the other one was super high end and bulky and whatever? Why did that exist?
Yeah. So the embeddable Ethernet switches that I have found have all been designed for military applications, so they are not cheap.
$12,000.
Yeah, not that expensive, but you're not that far off.
Yeah.
And when you look at the capability between them and a $35 Netgear switch, there's not that big of a difference. But a $35 Netgear switch, doesn't have the right connectors. Again, doesn't have the right monitoring. Doesn't have the right control interfaces or you don't want a web-based interface to configure your Ethernet switch if you're a robot. You want to send it a JSON blob that has all the information on how to operate and never do that again, or send it to it every time it turns on. So there are differences in how you build the product based on the end user and the end application.
Yeah.
And there's sort of a hole in the middle right now where things that are in the sort of heavy commercial light industrial space have a choice of consumer grade products that are cheap and don't last, or products that are overkill and too expensive.
Right. When I imagine that robot companies of particular sizes, they just, throw someone at the problem, right? They say, well, you're our electrical guy,
exactly.
Just go make this thing because we can't find it. And then that effort gets duplicated at, 40 different robot companies. So hopefully now you're that person.
That's exactly right. I know of 3 different companies that have built embedded gigabit Ethernet switches for robotic systems that they're building, and none of them are offering them as products because they don't sell products. They sell systems.
Right, of course. And so that's an interesting thing, though. is that going to, how, like your sales cycle then, is it going to be based on word of mouth or knowledge of some of these people, or how is that going to work? Or TBD?
Yes, and it's going to be long,
Okay.
because when unfortunately with the kinds of products that I'm building, you can't just immediately adopt them, or you can from a development perspective, but
Sure. Yeah.
there's definitely 2 or 3 years between a product being launched by me and it being integrated in a high volume production system,
Right.
because someone's not going to retool their already certified, already done system to save a couple $100 on an underlying component.
Right.
It just doesn't make sense. So,
Well, then you also have like obsolescence issues too, right? Because I mean, if you're doing what is not necessarily bleeding edge now, but even just consumer edge now, and then 3 to 4 years from now, you're gonna have to go through design cycles to
mhm,
maintain your product, and then
absolutely, and that's part of the value that I'm offering, that I see offering, because the alternative right now is to do this sort of thing yourself, and then you have to go through that obsolescence engineering yourself to keep building
sure,
the system you want to build.
yeah, yeah,
So, unfortunately, there's no way around that. You can do what you can to pick manufacturers of components that have guaranteed
yeah,
lifetime,
guaranteed,
but
quote unquote.
yeah, quote unquote, yeah, like it changes all the time. I know someone that bought up the world's supply of a particular component because that production line went down, and it
Yeah,
was the lead time went from 2 week to 30 week,
yeah,
and they had to plan 9 months of production all at once and buy the whole world out. So unfortunately, those sorts of things happen, but that pain is being felt everywhere, and there is value in sort of consolidating that and having one organization that's managing it and that has higher buying power, and hopefully more clout with suppliers as a result of that.
yeah, yep. One, it kind of also, I mean, you don't have to take this business model, but I always thought like, if you actually do make a successful thing and then you do build out some inventory and it, stockpile, 5,000 units, if you get in the right application, and I've always said that like my retirement plan is to like find that one component and then stockpile it and be a broker. It's like a total dick move, but man, you can make some good money. Just,
Yeah,
sell
I'm
100 a year at $1,000 a
I'm
component.
sure. Yeah, I'm sure you can.
Yeah.
I unfortunately, I don't think I could sleep at night if I ran that kind of
I
company.
could sleep like a baby, Chris, like a rich, loud baby.
On your giant piles of money.
That's
Yep.
right. Yeah.
Yep.
Yeah, but this actually there is a practical thing I'm getting to here too. Is that
Mhm.
is there any thoughts of like standardization too? So like standardizing an interface, because then if you move from Rev 1 to Rev 4, but the interface is the same, maybe the end
Yeah.
user doesn't
Then
care.
there's an easy upgrade path. Yeah,
Yeah,
absolutely. That's in ways, defining the interfaces between modules is one of the hardest parts of building a system. You
yeah,
don't want to sort of over add too much flexibility or future proof to things, because then you're carrying that weight and that burden,
yeah,
and you may never need it or use it. But if you design some component and it can only do exactly the thing that you need right now, you're going to be redesigning that component in the
that's
future
right.
when you need it to do something else. So yeah, that's a big part of what I'm trying to do here is think through applications and the future use of things.
I always find the risk of the biggest risk is actually the connector going obsolete.
That is a big one, yeah.
Yeah.
And just choosing the right connector too. Yeah, there are so many connectors, and it is still so hard to find the right one when you need
Yeah.
it.
Yeah. My hope for the VR systems of the world, I don't give a crap about video games or anything else that's out there. All I want is like a virtual Shenzhen market where I can walk through and just kind of pick up virtual components, look at them. And I know that's not actually a real thing that's going to happen, but damn, would that be great? Just because like I want to have like a sense of scale and I want to see, like
Yeah,
like what's the actual height of these things, and like all the things, how it snaps together, whatever. It's just really tough to do,
yeah,
virtual world, digital world.
yeah. I've heard that, I think it's IDEO. They have basically a library of materials,
Yep.
of samples of different plastics and composites and rubbers and fabrics, and they just sort of collect hinges and all these little building blocks to have at your fingertips. And I think there's huge value in that sort of collection, and having a couple of every kind of connector that you could possibly use just around, so that when you come across that next project, you can look at all of them and say, does this one feel right? Does this has the right latch? Oh, but I need it to be vertical.
Yeah, button feel. It's a thing.
Yep. It definitely
It's a great way to become a hoarder, though, too, just so you know. I mean,
yes,
you got to have a lot of storage space.
You do. Lots of bins.
Lots of bins. Yeah, I think luckily IDEO charges enough that they can have lots of bins.
There needs to be like a lending library for these things.
Yeah. I think the bits versus atom problem there is too, though, of like, it'd work great if there was, but it's like, at the end of the day, if I'm gonna pay to fly to, Pittsburgh or, California, why not just fly to Shenzhen, where it's the actual things that I could buy? There's almost like it's almost like a small adder at that point.
Yeah, but maybe this is something that local makerspaces should spend more time thinking about, is what component libraries should we have in-house? Because, I'd pay $50 a month to have access to, every button and switch and connector, and,
right.
That would save a lot of space and a lot of time and a lot of money to just like show up and peruse.
Have you been to a hackerspace?
I've been to ones in Pittsburgh. I've recently moved to New England and haven't been to any here.
I'm just thinking, like, how big of a mess that would be. They have trouble keeping like bandsaws in order sometimes. So I totally agree. I'm just saying maybe hackerspaces, makerspaces aren't the best place for it. Maybe libraries, like libraries would be great.
Yeah. Though, I mean, it's a different mission, but the library model of you check something out and then you bring it back in the exact condition that you checked it out.
Yeah, that's the key thing too. Yeah, that's a great idea. So, why haven't people done what you do?
In ways they have. There are companies that are building some components. Generally in a particular area of real difficult technology, like inertial monitoring or mapping or things like that. But I guess I'm not aware of someone doing this on sort of an infrastructure play. And my best guess on why is just the market is still really small, and it doesn't make sense for someone like Vallejo or Bosch or Delphi to pay attention to this market yet. We're just nowhere near the volumes of their existing customers.
Got it.
And even, people that are building components for factories, there's high volume in comparison to ground robotics. So we're still early days, but at some point, mobile robots are definitely going to be built the way that cars are built today, with huge supplier networks supporting those production lines.
Oh, okay. Interesting. I guess where else do you see robotics going then on the ground robotics side of things?
Everywhere.
I mean, like, because I look at a Roomba and I don't think like, oh, well, that's going to also be doing A, B, C, and D. I think like, oh, maybe like, I don't know, like, I have a hard time seeing that, but you obviously are very much into it.
Yeah, I guess there's a whole bunch of different ways that this industry can go, and or is going to be going, and it's sort of the value that you're bringing is definitely changes by the end user. But for instance, like in a house, there are all sorts of things that we do right now that we try to do right now that we often aren't doing. And cleaning's a good one of them. But I often think back to that moment in Fifth Element where the guy's choking on the
cherry
and bangs his desk. Yeah, the cherry. Yeah. And like all of these robots come out and they all have their very specific little task that they do.
A symphony of robots.
Exactly.
Yeah.
Right.
Each and with an engineer back home feeding their little babies so they can whatever. Yeah. Sorry.
Exactly.
I've seen that movie a lot.
None of them are able to save him, and it's a wonderful scene about the glory and the futility of robotics.
Yeah, it's true.
But like that is not the world we live in right now. Like you couldn't. Those things just aren't available, and at some point, technology gets cheap enough where it makes sense to have a robot that can bring you a glass of water, and that's all it does, and it's really inexpensive, and why not, right? Just like you can buy, packaged goods now that you couldn't buy previously because of cost and infrastructure and all sorts of other things. So
you're saying we're going to end up with a butter robot? Is that what I'm hearing? what is my purpose?
If you want one,
Okay.
if you want one, at some point it'll exist. Yeah.
Okay.
And in terms of, there's lots that are interesting in mobility and, personal mobility, especially for people that have a hard time moving around the world, people with physical ailments and people that are, elderly or have had physical accidents. Exoskeletons are really exciting and interesting. And that right now is, sort of, it feels very far off, but it's not going to be that long before we see people walking around with exoskeletons, because that's how they can walk around, and without them, they can't walk around. Huge value there. Yeah.
Cool. So what are some of the challenges you've run into so far as you're building out these robot components?
Time. Yeah.
Yeah. Okay. Also, it seems like, it seems like you have a wide background, but it does seem like the stuff you're building so far is very electronically focused.
Yeah, it is. So yeah, I've learned a lot of electronics in the last year. The gigabit Ethernet switch was perhaps not the best choice to build first from an electrical complexity perspective.
Okay.
First version had some issues. Second one's looking way, way better.
Good.
That's part of why I chose it. Was I wanted to expand my technical skill set and branch out a little bit more. So, learning a lot there. My biggest challenge is this curse that I have of way too many ideas and not enough time. And the list of things that I want to build grows faster than my ability to build them. Of course. Prioritizing and the normal time management stuff. It's exciting and fun, but it's also hard to be pushing forward on 4 different things all at once.
Yeah.
I need to wrap up a few things.
Are you actually interfacing with customers like based on known needs? Like, are you doing this based on your knowledge of the market, or are you doing this based on like them asking, like a set of customers actually asking for a thing?
It's both. And I've been learning about niches in the robotics market that I haven't personally worked in before. So things like logistics handling, picking and sorting, and sort of the package management, warehouse management side of things. There's a lot of interesting work happening there.
Oh, yeah.
And I see a lot of opportunity in new sensors and new ways of moving goods around. So that's an industry that I'm excited to help move faster. And also, there's a whole bunch of things that I'm excited about in camera systems. The amount of GPU power that you can put on a mobile system now is phenomenal, and what you can do with that GPU is really remarkable. But there, to date, still aren't really good cameras that can feed into those systems. And
interesting.
Yeah,
so it's all like those 2 megapixel like Raspberry Pi cameras, or what are we looking at these days?
Yeah, so there's this interesting thing that I've seen in a lot of customers where they give you a long list of, here are all of my requirements, and then you come back with like, okay, to satisfy all those requirements requires this amount of time and money, and the end unit cost will be X.
And there's a lot of zeros on X, I'm guessing.
Yeah. And they come back a little while later and they say, well, we found something that is X divided by 5 and only meets 2 of our requirements, and we're going to go with that. And there's a middle ground where there's a place for components that are a little bit more expensive than consumer grade, but offer a little bit more functionality than consumer grade.
Yeah.
And that's where I'm aiming, and that's what I'm excited about. So, things like the Intel RealSense, it's a wonderful piece of technology, a wonderful sensor. It's a low cost 3D perception system, uses active stereo where it's projecting a pattern of infrared dots into the space, and then left and right camera perceiving those dots just like your eyes perceive texture in the world, generating high density, real time, accurate 3D depth information. But it's really hard to put on a robot because it's not sealed and it's USB 3.
Right.
And,
also, like, how many can you buy at once, and are they actually selling them in quantity, and yada yada yada?
Well, those you can actually do. I've seen production robotic systems with a dozen of them spattered everywhere.
Oh wow! Okay.
Yeah, they have limited field of view, so you generally need many of them to sort of get a 360 degree surround view. But yeah, I've seen really big, heavy robots that use lots of those because they're cheap and because you can get them. And there's a place for a component that offers that kind of capability, but uses better interfaces and a better housing design and costs $50 more. And people will choose that, but they're not going to choose something that offers a whole bunch more functionality and, a 10x cost or a 20x cost.
Right.
You just can't, that trade-off doesn't sell in most markets.
Huh. And so how much of it is the mechanical piece? So if you have maybe that's that level of complexity you were just describing seems pretty high, but something like the USB hub, you talked about switching, you talked about monitoring and stuff like that, but how much of it is also making it packageable? And I guess I don't really understand what the mechanical constraints are when you get into the housing of electronics versus the housing of the motors and such.
Yeah, so it all depends on the scale of the system, but generally something that's using a whole bunch of USB sensors, and I do not recommend people use USB sensors, even though I'm about to start selling a USB-based product.
It's an in-between product.
USB, yes. USB is not appropriate for mobile robots. But it's great for many other things, including automated testing of embedded electronics, which is where I'm going to be focusing that USB hub marketing efforts on. So, but anyway, if you're building a system that uses lots of USB sensors and you're using a USB hub right now, there's generally some kind of large enclosure that you can open up and has a ton of wires inside, and technicians going in there and rewiring things, and swapping components in and out. So that component is not going to have a sealed housing and sealed connectors. It's designed to go inside an existing enclosure that has enough space for it to exist in.
Got it.
But the value that this version provides, in comparison to something you would buy from Anker or Belkin or whatever, is locking power connectors, mounting holes, a metal enclosure, higher temp rating, power monitoring, and the power monitoring chips aren't that expensive, but when you're trying to sell something that has a $5 bill of material, you're not going to spend $1 on the power monitoring chips.
Right. And that's just to tell if it's overcurrent or something's wrong, basically.
Yeah, and which port is drawing too much power, right? So the sensor that was drawing 100 milliamps is now drawing an amp. Something went wrong. Maybe there's a short in the cable. Let's turn that off, right? So that the whole USB bus doesn't go down. And also includes a 8 amp 5 volt regulator on board. So each downstream port can draw 2 amps at 5 volts, which again adds some cost to the unit, but means that you can basically throw anything you want at it and it'll power it.
Yeah. Yeah. That's nice.
Yeah. There's with a little bit of additional cost, you can really add some interesting capability. And the hub chip that I've selected also has a hard fifth endpoint on it that exposes UART and I2C and SPI. So I've put a microbus header on the PCB, so you can actually use this as a USB hub and also a physical world expander. So hook up some sensors to it, hook up relays or an IMU or any other device that operates over a UART, I2C, or SPI, and you can talk to it through your USB hub without using up one of the USB ports.
This is the microelectronica 10-pin standard or whatever it is?
Exactly. Yep.
Yeah. Okay. Cool. Yeah, that's a great idea. It's good to make it extensible.
Yeah, and there's a whole bunch of different modules available for that. So a nice way to offer some flexibility instead of doing different versions for different customers.
Cool. So, I'm still curious though about the design, how you're sourcing these ideas. Is it known customers, or it's based on your past knowledge, or what, or mix?
It's both.
Okay.
Yeah, it's a mix. I've been in this industry for 15 years now, so built up a good network of people in all sorts of different little and large parts of the industry, and there's no one building a system really cares about the components that are inside of it. They just want to buy and find the right things. They care about the problem they're trying to solve,
right?
And if you have a nail and they need a nail, they'll buy the nail instead of make the nail.
Right.
Yeah.
Well, I'm just wondering though, is like how you start a conversation like that, because I don't think, we've
Yeah.
talked about product development before, but I'm not sure we've ever
Mhm.
talked about like having a direct insight to a customer like that. Like that's a very very valuable thing, I think. Like you already mentioned that you can ask them everything they want. They might say everything they want, but then the price balance is there. But like being able to just ask in the first place is pretty valuable.
Yeah, it is. But there's also this fallacy. When I think about the products that I want, I have the same problem where people think they're going to use features that they don't actually use and that they're not actually willing to pay for. So you have to balance what people say with what everyone else says, and
Well, when they
find the
pull the
right
wallet out,
mix.
right? That's the real
Yeah,
that's the real
yeah,
thing.
yeah, yeah. And it's tricky to get them to do that ahead of time, right? So it's a balancing act, and you have to definitely use your intuition and iterate. It's a
Yeah.
really big part of this.
Well, I just wonder too, is like, so one of my friends, it was a sales guy, and he used to basically, go to engineers, get them to draw up a spec sheet or like a data sheet for a thing. And then he would
Mhm,
go and he would actually get sales based on that data sheet. It was kind of insane,
mhm.
but also kind of brilliant. Like it was basically selling it before it existed. And then the fact that he sold it, with a very long lead time, meant that it was worthwhile to
Yeah,
go build it. Right. And so I wondered if you were doing
right.
anything like that.
Yeah, I've actually tried that. I've gone to I mentioned going to the factory automation industry. I went to a trade show there with uh, 6 potential spec flyers to show people and talk about,
Hmm.
and got some interesting feedback on different versions of different products that I'm considering, and just gauging people's reactions. What lights up their eye. What do they gravitate to? What do they say no about?
Yeah.
There's tremendous value in that sort of feedback.
Did you bluff though?
Um,
That's what I'm really wondering, is because as much as I admired my friend for being able to do this, I was just like, man, the stones on this guy. Like the fact that like, but people like sales guys do this all the time. Sales people do this all the time,
mhm.
and I can't imagine walking in and being like, yeah, this exists, and it's not even close.
I definitely was not saying that these things existed. I was saying these are spec sheets for future products. I would like feedback on them,
Yeah,
and I
okay.
got feedback on them, and
Okay.
that was very valuable.
Mm.
And I think that the whole idea of this company, as you say, like there you know, there isn't an obvious, oh, but these people have done what you're doing, and that's part of why I started with this Ethernet switch. Is it's a way to open the door, the conversation with a potential customer.
Uh-huh.
Everyone knows what an Ethernet switch is, and when you say you're making a new kind of Ethernet switch, that perks their interest.
Sure.
Wait, what do you mean? How is this different? Like,
Right. Why do I care about
would I
this? Right.
choose that? Yeah,
Yeah.
why do I care about this? And like, what do you mean you're doing an Ethernet switch? Like, what do you mean you're doing a USB hub? Like, but then when you start talking to people about these interfaces, mechanical and electrical and software interfaces that are different on these components versus existing products, then they start to get it and understand that this model can be applied to the problems that they have. Maybe they don't even use Ethernet, but it gets them to reconsider what they're buying and what they enjoy about that and what they're unhappy with when they're
Right.
buying or building.
Right. Yeah. And I think that's actually a really good point too, because at the end of the day, if you talk to the person who's actually in charge, right? Like talking to your former self as CTO, you're basically saying to
Mm-hmm.
them, hey, I'm going to save you a crap ton of money. Like you could either pay an engineer,
Mm-hmm.
and as an engineer, it hurts me to little say that, but like, if I can buy a component that is 4 months of my time and it's guaranteed to work the first time, it's stupid not to do
Yeah,
that.
no brainer. Yeah,
Yeah.
no brainer. Yeah,
And then hopefully
yeah.
you
It
deploy your engineers
reduces.
to go do that next thing that's interesting. But
That's exactly right. And
yeah,
to tackle the really hard problems that are specific to the domain that you're facing.
hmm
Yeah, that's the goal of the company, is make it easier for people to get to market faster and with a system that is more capable and more effective.
that's great. Well, it's like it is. It's in the name. It's in the name.
It's in the name.
Yeah.
Yeah, it was really funny. I spent a long time thinking about names and the sort of vision and mission for the company, and in the history of the internet, no one had ever registered capablerobot.com, and because to people outside this industry, or this is my guess at least, to people outside this industry, that sounds like a low bar. Like a robot that's only capable, like
Right.
why not a fantastic robot
Right.
or a wondrous robot?
Right.
And to people in this industry, you're like, oh, capable, like that's what we need.
Right. Right.
Yeah,
Right. I'm not worried. I'm not worried about any kind of revolution here. I'm just worried for the thing
Right.
to, last its entire
Just
battery
want
life.
exactly, and
Fit together
I
when
don't
when I screw the thing together.
right, and I don't want the connectors to rattle loose inside, and so on and so forth.
Yeah. Right.
Um,
Running out of Loctite.
Yep. They make a good product.
Yeah. Oh yeah.
Yeah. So there's a mismatch between like people's perception of this industry and the reality of it in terms of how difficult this is, and every part of this is tricky. You're making a system that has to interact with people, move around in the real world, bring its own power, be safe, be big enough to actually do something
not kill
useful.
the humans, like that's important.
Yeah, or the pets or anyone else, right? And be small enough that you can maneuver, but big enough that you can actually do something useful. And it's just a world of overlapping incompatible constraints. That's what robotics is. And that's what makes it really fun and exciting and interesting, but also really difficult.
Right.
So I'm trying to make it less difficult.
Robotics is a world of overlapping, incompatible. I'm gonna lionize this one.
Constraint.
Yeah, got it. There you go. There's the tagline on your T-shirt right there.
I guess so, yeah. But that's what makes it fun. I mean,
sure.
It's a world of really interesting engineering challenges.
Yeah. I mean, where do you see? So I'd ask kind of like where you see ground robotics going, and that is the term, right? You're saying ground robotics.
Yeah, ground robotics. Yeah.
So what about like opportunities for people that are listening in terms of maybe not necessarily a company they're going to start that is robotics, but like if they're looking for a job, like where should they be looking for a job in robotics? Or like what skill sets would be useful, as a former CTO and like hiring engineers, what would be useful as a, if an engineer walked in a door for an interview?
Yeah. So to work at a robotics company, you definitely need to know, you don't need to know anything about robotics. Like you just need to be an engineer because again, robotics is a combination of all of these different disciplines. So, we hired many, many people who had never worked on any robot ever, and they were fantastic because they were working on the embedded software on the safety system, or on the machine learning system, or on data management, or whatever else infrastructure needed to exist to make the system work. And similar skill sets in electrical engineering, power systems, sensor design. We didn't do much with analog circuitry, but if you lay out a PCB quickly and it works, you're golden. Interfacing to processors, interfacing to sensors, understanding communication over cabling of up to several feet, understanding radios. There's a whole every kind of electrical engineering technology really goes into these systems. You're talking about power management and high level computing. We built robots that had M3 microcontrollers and Xeon processors in them, and everything in between. So it's just sort of the entire spectrum of electrical engineering can be encapsulated in robotics, depending on the kind of system you're building.
Well, I was just going to say, with the amount of compartmentalization that you're talking about too, it sounds like the ability to work with other groups is probably one of the most critical things as well, because you're going to be doing some sub piece.
Yeah, absolutely. But you can definitely learn. You don't need to know or have functional mechanical engineering knowledge if you're a software engineer.
Oh, no, I meant more interpersonal and team. Team playerishness.
That's yes. That is an absolute requirement. You're going to be working with a team. There's no way to build these systems without a whole bunch of people. And that's, to me, that's what makes it a lot of fun.
So like some amount of like fluency in mechanical doesn't really matter though?
No, not at all. Just be upfront about what you're interested in and what your skill set is and what skill set you want to expand on. And, there's lots of opportunity out there. It's a industry that's hiring everywhere. I'm happy to talk to people if they'd like advice on where to go, where to apply, particular facets of the industry or places in the country that have lots of companies and activity.
Yeah,
there's a lot going on. Yeah,
that's great. Well, how do people get a hold of you? And that's probably a good way for us to wrap up here.
Yeah, absolutely. So on Twitter, it's just my last name, Osterwood, Osterwood, and Osterwood.com is my personal website, and the company website is capablerobot.com.
Nice. Well, Chris, thanks for telling us about all this stuff. It's been a lot of interesting, like in zigs and zags in terms of the robot industry. I didn't quite know what what it all involved, but it seems like there's a lot of fun challenges there.
There really are. It's a great place to be, and I'm really glad I sort of accidentally landed in it. And I would definitely encourage people that are looking for interesting engineering challenges to reach out. And look in your local city to see what robotics companies are there, and I bet they're hiring.
Awesome. Well, we will. The people should definitely check out capablerobot.com, and we'll look forward to seeing your next project.
Yeah. Well, actually, my next project is launching next week on Crowd Supply.
Oh,
we
didn't get to that. Oh man, what's that?
We didn't even talk about that.
Sorry.
That is called SenseTemp. It is a small 4-channel temperature sensor designed for instrumenting electronics. So this is something I've designed along the way in testing other products that I'm developing. It's designed interface to the Adafruit Feather host boards and provides 4 channels of really accurate temperature monitoring and small RTDs that you can place right on ICs on your board and understand heat sources and sinks and the thermal path and dissipation of whatever component or product you're working on.
That's great. And so that's going to be on Crowd Supply starting next week, you said?
Next week, yeah. Open source hardware, open software, and designed to be hackable and extensible and integrate with current and future test orchestration software that you may be using.
Awesome. All right. Well, people should definitely check that out too. We'll have a link to all these things in the show notes.
Thanks so much, Chris.
All right. We'll talk to you soon.
Thanks. Bye.